Hi guys, welcome once more to my online tutoring, and in this video we are going to discuss the properties of derivatives part 2. So in part 1 we discussed the beginning properties like the constant property, the constant multiplier property, and the sum and difference properties. In this video now we want to look at the power rule part 2. In the next video, we'll be looking at the quotient rule. So in previous video, I derived this power rule, but for this video, we're just going to see the power rule and know how to apply the power rule on few problems. So let's get started. Now, what is it about the power rule? Let's get to know just everything we need to know about the power rule. Now let's consider a function to be differentiable function. Say, let x be a differentiable function. The first one. The next one, let n be any real number. Then y equals to x raised to the power n, which is now a function, will just give us y prime, which is a derivative, to be equals. Now we drop this n and we rewrite x and subtract 1 from n minus 1. If you want to use other notations, you can say dy by dx is just equal to n x raised to the power n minus 1. That's it. What if you also want to use a function f of x right there instead of just saying x, right? So we could say y equals f of x raised to the power n. So whatsoever function that is in here that is raised to this power n, the rule says to find the derivative y prime, bring this power down, which is n, and then rewrite this function f of x. Then you subtract 1 from that power, n minus 1. Done. Right? So the next thing now we need to do is to find some examples problems that we can solve. Let's get some example problems. Find the derivative of the following problems. Question number 1. Y equals x raised to the power 5. So x now represents this x and 5 represents n. So now we're going to say y prime would just be equal to, we bring this 5 down, 5 x raised to the power 5 minus 1. So now we have y prime to be equal to 5x raised to the power 4. This is the derivative. Let's look at another problem. Question 2. Let's say f of x is equal to a function f in x equal to 3x raised to minus 4. Right? So to solve this thing, we say f prime of x Whenever you see this notation, it means the problem has been differentiated. Then we multiply. So we say 3 multiplied by this minus 4. Remember, we said you should bring this one down, multiply by this expression, right? X raised to the power minus 4. Then we subtract 1 from minus 4. So this now will give us minus 12 x raised to the power minus 5. Great. So this is f prime of x. What? Now let's solve another problem. 3. Now we say let's find some screench problems, right? So we will say g of x is equal to 2x raised to the power 1 over 3. Ho, ho, ho. So to differentiate this problem, we say g prime of x is just equal to 2. You bring this whole power down, 1 over 3. So it means you're going to multiply it. Then you say x raised to the power 1 over 3 minus 1. So g prime of x will now be 2 times 1 is 2 divided by 3. X now will be raised to the power. Now, use the shortcut method, right? Say 3 times 1 minus 3. So it's minus 3 now, and then this positive 1. Minus 3, you add this positive 1 to it. All must be divided by this 3. That's a shortcut. So 1 minus 3 now is minus 2 divided by 3. This is the problem. Simple, very, very simple. So these are some of the problems. Let's do this last bonus question. Y equals to the square root of 10x. Hey. So the first thing we need to do is to rewrite this thing in this form. Because you see here a variable or a function raised to a power. So we must rewrite it in that form. So we say y equals 10x raised to the power. Now square root means 1 over 2. Right? Very, very simple. But you have a number and you have a variable. So we can rewrite it as y equals 10 raised to the power 1 over 2 times x raised to the power 1 over 2. Because the rule says if you have the square root of a times b, if you want to rewrite in exponent, it can be a raised, let's say a times b raised to the power 1 over 2. This is also equal to a raised to 1 over 2 times b raised to 1 over 2. So this is exactly the method we're using, or the property that we are using. So now this can be y equals, now let's differentiate now. So this is, remember, 10 raised to 1 over 2 times, we bring this power down, not this power attached, let's say on top of this 10. No, this is a number. This is the variable that we are discussing. So it's 1 over 2 x raised to the power 1 over 2. Then we subtract 1 from there. Man, you don't say 2 here 1 times 2 into this 10 times. No, don't do that. This 10 is under a radical, the square root. So this is square root of 10. All divided by 2. X now, 2 times 1 is 2. negative 2, and then this positive 1, all divided by the same denominator 2. So 1 minus 2 is minus 1 all over 2. If you want to simplify it further so that you cannot have negative in your power, you can say y equals, now remember, now this is y prime, this is y prime, and this area is now y prime because this was where we started differentiating from. So you can say the square root of 10 divided by 2 times, we can turn this one around because this is divided by 1. So we can send a 1 on top, and then we bring this x to the power 1 over 2 down. Right? So you can further say y prime equals the square root of 10 divided by 2x raised to the power 1 over 2. Or you can say x, the square root of x. That's what you can say. Or you can put this 10 and this x under one radical. That is, now, please, I beg you, you can just stop here, right? You can just stop here. This is okay. I'm just trying to simplify for every other person that want to have a kind of simplified problem. You know, maybe your instructor wants you to simplify it further. So we can now say this is the square root of 10 divided by 2. This is the square root of x. Now, the rule says if you have the square root of a all over the square root of b, this can be written as the square root of a all over the square root of b. It can be under one square root. So y prime is equals, now this one and this one, they are the same square roots. So we can put it under one square root by saying, now the coefficient is 1, right? So it's 1 over 2, 1 over 2. Then we can say 10 over x. So thanks very much for watching. See you in our next video. Bye.